It's Neil Gorsuch, Associate Justice of the Supreme Court of the United States.
How do you just know who that is?
All right. All right, I need you to stop talking. Okay. So the first part is just ideas of confidence intervals. And so we're going to make sure that we can interpret it, a confidence interval in context, and you can explain the confidence interval gives a range of plausible values. So, yeah. All right. How much do the volume of bottles of water vary? A random sample of 50 20-ounce water bottles is collected and the contents are measured. A 90% confidence interval for the population mean mu is 19.10 to 20.74. Interpret the confidence interval. So what you need to make sure of is that you understand the difference. The first one asks for confidence interval, and the second one asks for confidence level. Okay, so know the difference. So the confidence interval is the one that we've been doing the entire time. Okay, level we've done like twice, and that was it. So make sure that you understand what you're doing on that one. So this one is our confidence level was 90%. Confident that the interval 1910 to 20.74, and you can write it as that, or you can write it as like a coordinate. The interval captures the true, and then we were talking about the population mean. So the true mean. And in context of the problem, contents of a 20-ounce bottle of water. So again, that's one we've been doing this entire time. When you get to your free response, you'll be doing that a lot. So if free response asks you to construct an interval, you have to do all the tests. You have to, basically your state plan do conclude, but you don't have to write out state plan do conclude. You just got to do all the steps on that. Okay, so every time. All right, so the one that you're probably not familiar with is the confidence level. We did do that a couple times, I think in 8.1, maybe once in 8.2, but we have done it. Okay, but we haven't done it a lot. So you may not know. So confidence level is if we were to collect many samples of 50 water bottles. Okay, so the 50 is the sample size.
I can't see the board. Just let me know.
Do you have your sound on? It'll be weird. It'll have feedback.
No.
Okay.
It's muted in there.
Yeah, but me talking is what I'm talking about. Sorry, it's a little confused. All right, if we were to collect many samples of 50 water bottles, so that was our sample size, 50 samples of water bottles, and construct a confidence interval for mean content %, of the intervals would capture the true mean. Squeaking? We can change it out if you need to. After we finish this review, if you want to change it out, change it out. That way you won't be sitting in it tomorrow. All right, any questions on that? So the things that change in this one, is your sample size and whatever you're sampling. Whatever it is, it might be a proportion, so be ready for that. So this was mean content. It could be the proportion of all young women ages, blah, 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 whatever it is in context of problem. Your 90% will also change depending on your confidence level. So if it could be 95, 99, whatever. And then this part right here, whatever you're looking for, that could be proportion instead of mean. All right. Based on this interval, what can you say about the contents of the bottle in the sample? What can you say about the contents of bottles in the population? So what are they supposed to be? What kind of bottles are they supposed to be? 20 ounce. So look at our interval. So what can you say about that? Just talk. What can you say about that? Y'all are real good at talking. What do you mean? Talk about this interval though.
It's plausible to believe that the true meaning is really close to 20.
Why?
Because I'm capturing in the.
Does that make sense? That's all it is. Was that 20 inside of the interval? Yes, it is. Here you go. We don't have evidence. This is to prove otherwise, okay? We don't have evidence that suggests bottles contain less than or greater than 20 ounces on average. And you're absolutely right, because the 20 is inside of the interval. If our interval was 18.10 to 19.74, we could have evidence to claim that they do not contain 20 ounces. Got it? So the average is not in the interval, so it is plausible that they are incorrect or false advertising 20 ounce bottles. Got it? Okay. All right, flip it to the next one. A large company is interested in developing a new bakeware product for consumers in an effort to determine baking habits of adults. So researcher, be careful and make sure you read every part of this, okay? Don't just see the bottom and say, okay, this is what I'm doing. All right. Determine baking habits of adults. A researcher selects a random sample of 50 addresses in a large Midwestern metropolis area or metropolitan, good gracious, area. She calls each selected home in the late morning to collect information on their baking habits. The proportion of adults who bake at least twice a week is calculated and a 90% confidence interval is constructed. Discuss whether or not each of the conditions for constructing a confidence interval has been met. If any of them have not been met, discuss the implications on the interpretation of the interval. All right, so what are conditions that we need to meet? Okay, random. 10%. And it's what? Is it? Large what? Counts, good. Why is it large counts? Because it's proportions. Good. All right, so there we go. All right, is it random? Okay, so I heard a yes and a no. Let me talk about the yes first. Why are you saying yes? Because it does say a random sample of 50. Why are you saying no though?
Because she had it all.
She called them. When did she call? So tell me about late morning. So who's not at work? People that maybe like stay-at-home moms, stuff like that. So what are the chances that they bake? Probably higher because they have time to do it, right? So that's what we have to, you got to encompass everything that's in the problem. So this is no. Because of calling, and just like you said, we could have some non-response there. And it's also because it's in the late morning. Okay. So late morning would be under coverage. You guys understand that? So there are two biases happening right here in this experiment, well, not in the experiment, but trying to construct this interval. So you said, because it says discuss the implications on the interval, it would be an overestimate.
I have a question.
Question away, girl.
Okay, so even though that it says random sample, it's not because of the bias.
Yes,
Okay.
because of the time that she calls and because of actually calling. Because think about it, how many of you pick up your phone when a random number calls? Hardly anybody. So there could be under response, and under coverage, or non-response and under coverage. So just make sure you read the whole problem, okay? I'm not sure that there are any of those on your test. If you have those, they'll be within the, I think, in the multiple choice problems. So just be aware of that. All right, 10%. We took a sample of 50. We multiply it by 10 and we get 500. Do we think that there is more than 500 adults or addresses in a large Midwestern? Yeah, so we're good there. So we don't have to worry about the implications because it's fine. And then your large counts, remember, is going to be n times p or n 1 minus p. And then, do you think that that's going to be okay? What do we use when we don't know? 0.5. So if we don't know, we have 50 times 0.5 and 50 times 0.5, and both of those will be greater than 10 or equal to 10. Is everybody good? All right. And again, this one is kind of iffy on here. Typically they'll get, I don't like that they didn't give you a proportion. Okay. So typically they'll give you a proportion for that. So those are okay. This is the one that was important. So make sure you watch, even though it said random sample. Yes, we did take a random sample, but there's a lot of bias in how they worked out the experiment or the survey. Okay. Look at your next one. All right. All of your formulas are on here, just to let you know. They tell you exactly what to do and how to do your state plan do conclude. So I would suggest that maybe when you're doing your work tomorrow, you might want to check this out a little bit, because I'd be dumb to think you didn't. I know how y'all like to look at each other's stuff. So be ready for that. You're going to have it, okay? So you're going to have to know how to do these questions. So according to a recent study, not everyone can roll their tongue. A researcher observed a random sample of 300 adults and found 68 who could roll their tongue. Use a 4-step process to construct and interpret a 90% confidence interval for the true proportion of adults who can roll their tongues. So in the AP exam, they are not going to tell you to check the conditions. They will not. They'll just ask you to construct the interval, and you will have to know which one to use. And here's how you know which one to use. Okay, it is a proportion. Also, I have your 8.1 and 8.2 homework. I have your 8.3 part 1 homework up so you can check it. 8.3 part 2 will go up at the end of this period because I am waiting on people to turn that in, and if they don't have it in by the end of the period, it's going to be a big fat 0. Okay, I'm not going to wait anymore. Is everybody good? All right. So your state, we're doing a 90% confidence.
Miss Jones,
Yes.
was that the homework from yesterday?
Nope. Yesterday was Albert.
Oh, I meant the day before that.
Yes, ma'am.
Okay, I've turned it in. Okay, I was just making sure I didn't miss something.
Yeah, you better not miss anything.
No, I didn't.
All right, 90% confidence. And we want the true proportion of who can roll their tongue. You need to write out the procedure that you're going to do. We're doing a 1 sample because we're only taking 1 sample. We're doing Z. How do we know we're doing Z? Because it's a proportion. We're making an interval. Again, 4 proportions. Our formula is at the top up there, but I'm going to remind you of it. It's going to be p hat plus or minus z star, and then your standard deviation that has the p hat in it. So p hat 1 minus p hat over n. What I like to do at this point is define all those variables. Okay, so I would suggest that you do, it does not matter where it's at on your paper. You can do it all different places. It doesn't matter as long as you have it. Okay, they'll check everything. If you write up here, they're going to look at everything that you write. So if it's something that's wrong, erase it or mark it out. Got it? If you leave it blank and if you leave it just normal and it's on there and it's something that's incorrect, like a different Z star, then they're going to count your problem wrong. Okay, so anything incorrect, you can mark out or just erase or whatever. Yes, ma'am. Anything that's wrong makes it wrong. I know. Y'all, I'm telling you. So we're going to start with p hat. P hat said that 68 out of 300 could roll their tongue, which gives me 0.23. My N was 300. And then the only other thing that I need is Z star. How do I find Z star? How? Inverse norm. What area are we looking for if it's a 90% confidence? 0.05. What's our mean and our standard deviation? Why is it that? It's standardized, so we normal. Yep, standardized. I'm going to go ahead and tell you when you put this in your calculator, you get 1.645. I would round to 3, if not 4 decimal places. Okay. I then put it in my formula, 0.3 plus or minus 1.645. You do not need to do this. It is not necessary, but I like to show you guys what I did. Oh, we did. I did not. But we do need to. Sorry. We'll go back and do it. Yeah, I missed the whole plan part. It's okay. I missed the whole plan part. I missed the whole plan part. Yeah. Yeah, I missed the whole plan part. It's okay. It works. We'll go back and do it. I apologize. All right. Your interval ends up being 0.1869 to 0.2664. I'll go ahead and throw your plan over here. Is it random? Why? Yeah, and you can just put stated. 10%. We do 10 times, not 6, yeah, 68. No, 10 times 300. Sorry, y'all. I'm struggling today. It's literally been all day. Do you think there are more than 3,000 adults? Yes, so we're good with this. And then what are we doing here? Large counts. And we're doing NP and N1 minus P. Y'all, that's all you have to do. Both are greater than or equal to 10. You don't even have to put them in there because you've already defined N and P. Does that make sense? Yes, no, maybe. Okay. So sorry that I didn't do your plan. All right, last thing, conclude. How do we conclude it? Stop right there for just a second. We are 90% confident. Keep going. Got the interval, include that interval in there. 0.1869 to 0.2664 does what? Captures the true proportion. Make sure you write this out completely tomorrow. the true proportion of, what's that keyword you got to put in there? All what? Keep going. Who can roll their tongue? Yes, it has to have all of it. Sorry, I don't know why I missed the plan part. All right. Everybody good with this one? The next one, I actually did 2 different ways, and I think you would get full credit for both ways on your AP exam. And here's why. When I did it the first time and I was working it out, it says the researcher would like to estimate the proportion of adults who can roll their tongue. However, unlike the previous example, she'd like to estimate to be within 2% at a 95% confidence level. So I used the same proportion from the first one because it was talking about rolling their tongues. What do you use if you don't know the proportion? 0.5. So we're going to do it both ways. And just as long as you say from the previous example, the proportion is blah, 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 then you should be okay. I would take either one on your free response. Does that make sense? So I don't think any of mine say from example 2, use the proportion. I think it says it within the problem. So it's just a whole separate problem. If it's a completely separate problem, use 0.5 if they don't give you a proportion, okay? On this one, because it says the previous, I would have taken both. So I'm gonna do both for you, all right? So here's our formula up here. Remember, the only way it changes is if when we get to means, like this, it's the same formula, guys. Just when we get to means, this part changes, okay? So Z star times the square root of P hat 1 minus P hat over N has to be less than or equal to the margin of error. What is our Z star for 95%? Our proportion, this one I'm going to use our proportion from the other time, which was 0.23. And again, I'm only doing this because it's the same problem as the other one. So where did the 0.23 come from? It came from the other problem. Less than or equal to, and we want it to be within 2%. So what do I get at less than or equal to? 2% is 0.02. Okay, make sure you change it to 0.02. How do I solve? No, because you're doing plus or minus 0.2. You're good. All right, so we get the square root of 0.23, 1 minus 0.23 over N less than or equal to, I'm going to tell you that this is 0.0102. What do you do now? Get rid of the square root. We get 0.23 times 1 minus 0.23 over N is less than or equal to. This one is crazy, 1.0412 E negative 4. Watch that right there. You don't want to screw up because you get that and then you don't type it into your calculator or something, okay? Watch that E negative 4. Y'all know how to put that in your calculator? I just keep going through my calculator and doing like the answer or whatever. But if you need to write it, like if you need to type it in, if you look at the comma, right above the comma is EE. So it'd be 1.0412 and then do second and comma, and it'll give you that E negative 4. So you can type it in, that's fine. I just wanted you to know where the E key was just in case you needed it. All right. So then remember the cheater method is you just interchange these. And when you put that in your calculator, you get 1700.86 is less than or equal to N which means that n has to be greater than or equal to 1700.86. But we want a whole number and it's going to be the next one up. So n has to be greater than or equal to 17.0 or 1701. So this is the first one that I would accept. And again, it's because it asked about the previous problem. But because they didn't give you a proportion in this, if it's a brand new problem and they don't give you a proportion, you're going to use 0.5. So it'll be the same work. You'll have 1.96, except for this is going to be 0.5. 1 minus 0.5 over n, less than or equal to 0.02. You'll go through the same exact steps. And you'll get n is greater than or equal to 2400.99, which means that the sample size would have to be 2401. Greater than or equal to 2401. So that's a big difference, okay? But would this sample size give us the same results? Yes, okay? Because it's bigger. What is a bigger sample size going to do? Reduce variability. This is, again, the maximum that you could get. So if it asks you for the maximum amount, then you're probably going to use this one, okay? Moving on. No definitions, 8.3. You listen to me carefully about this because this is the easiest part of the test. And because you don't read the directions and you don't use your book, you miss the questions. Okay? Does everybody understand that? I think there are 6 questions on Z stars and T stars. Z stars and T stars. You need to be careful and make sure that if it asks you to use table A or table B, that you are using the table. Everybody got it? All right. So when we look at this, it says an 80% confidence, use the T table. We're talking about T's. So this table B. To determine the critical value T star that you'd use for a confidence interval for a population mean mu in the following situations. So anything in your book, I think it goes 1 to 30 and then it goes 40, 50, and then 60, 70, 100, something like that, okay? So anything within that range, 1 through 30, you can use your book or your calculator. It doesn't matter because it's going to come out the same. So this one, you can use, because it's a sample size 19, you can use your calculator and it will be fine, okay? But if they ask you one like this, this one right here, 248, you know that's not in your book. So you have to go to the one that's least, and we'll get to that in a minute. So again, if we're looking at our book, sorry y'all, worst sound in the world. And show your tables, and thank you, I have put your tables up there. Thanks for letting me know. When we're looking at our degrees of freedom, our first one, we said 19, sample size is 19. So what's our degrees of freedom? 18, and our confidence was 80%. So if we look at the bottom, I'm trying to get it on here, right? Here's 80%. We had a sample size of 19, so we have to go one less. So we should get 1.330. Everybody got it? If it is perfectly in the table, you can use your calculator. Okay, I don't mind that. All right. So how do we do a T star in the calculator? Inverse T. We wanted 80%. That means 20% is left. We have to split it in half, which gives us 10%. What were our degrees of freedom? 18. And we still get 1.33. Give me the positive, okay? Give me the positive. So any questions about that? That's how you use your book and the calculator. So the first answer should be 1.330. Try to go 3 decimal places. All right, look at the next one. B is the one that you have to use your book on, okay? So it says use the table. A 95% confidence, so we're going to look down here for 95. And it says 248 degrees of freedom. I do not have that on here. I do not have 247. Does ever, well, this says 248 degrees of freedom. So it doesn't matter, it's not on there. What would I use?
You still got chocolate?
It's over here.
You got caramel?
Yeah. So we're going to look in our table to the degrees of freedom. That's the next least, okay? There's an open box, but I don't know if there's caramel in there, but there's a completely new box underneath it, okay? So this one would be 1.984, 1.984. You guys got it? So B has to be 1.984. Watch what happens when you put it in your calculator. If we want a 95% confidence, what's our area? 0.025, right? There's 5 left, and then split it in half. Our degrees of freedom, it said, was 248. You're welcome. Thank you. And we get a lot different, right? You guys see that? You will get it wrong on your test if you give me this answer and it asks you to use the table. Fair enough? Y'all understand what I'm saying? Read. Okay. So then the next one is a 99% confidence interval for the sample of size n equals 30. Can we do that from our book? Yeah, we have 29 degrees of freedom, right? So this one you could use calculator or book. It would give you the same answer. It doesn't matter. All right. So anything 30 or less, you guys can use both your calculator or your book. It doesn't matter. So this one says 30 with a confidence level of 99. So find your 99, find your 30, and you get 2.750. What? Oh, 2.756. You are right. You're right. 29 degrees of freedom. I just didn't go. That's what I have on my paper. I just didn't go up high. Is everybody good? All right. Put this away. This one says the amount of sugar in soft drinks is increasingly becoming a concern. To test sugar content, a researcher randomly sampled 8 soft drinks from a particular manufacturer and measured the sugar content in grams per serving. The following data were produced. Use these data to construct and interpret a 95% confidence interval for the mean amount. Mean means we're going to use T in the manufacturer's soft drinks. All right. So what do we have to do first? We're going to do our state, which means we're going to do a 1 sample, what? T interval, that's what it asks us to do. For what? We did Z for proportions. What are you doing T for? Means. And we want 95% confidence. Plan. What do we got to do in here? Check your conditions. What are your conditions? Random, 10%. What else? Normal or large sample. Remember, if it fails large sample, we have to tell if it's normal or not. What if it fails large sample? We graph it. Make sure you put, if you graph it, assume normality and say why. And we'll talk about that in just a minute because we are going to have to graph this one. All right. So is it random? Why? It's stated in the problem. 10%. How many samples did we take? 8 times 10 is 80. Do you think there are more than 80 soft drinks in the population? Yes. But our large sample, n equals 8, which is not greater than or equal to 30. So we have to graph. And I think mine are already in here. 20, nope, they are not. The last one is. All right, so you're going to put them, wow. I was like, what was so loud? 26, 31, 23, 22, 11. Tell me if I put them in wrong. And 31. I think they're good. All right. Remember, we go to second y equal, not second y equals. Stop it. Yes. Second y equals to get our stat plot. We're going to turn it on. And we're going to make the modified box plot. Why do we want the modified box plot? If it has outliers, it is not good. Does everybody understand that? So we want the modified so we can see those. Okay. And then once I get that, I'm going to zoom 9. Oh, sorry, I have something in y equals. Let me get that out so you guys aren't looking at it. All right, Zoom 9. What do we see? Yeah, it's a little bit skewed, right? It is a little bit skewed, correct. I'm going to graph it on my paper. I'm just going to trace it. So we have a minimum at 11. We have a Q1 at 18. A median at 22.5, 28.5, and a max at 31. So it's slightly skewed, but it's nothing that throws it off. So that means there are no outliers or strong skew. So we assume normality. You have to write that. You have to. Okay. Since we assume normality, we can continue with our interval. So we're going to go to the do part. What is our formula? We're doing means, so it has to be X bar. That's our point estimate. Remember that. We're using T-star because we're doing means. The difference in the formula is it's the other standard deviation, the standard deviation of the sample over the square root of n. Now, on this, I cheat. Okay. Remember, I told you, I would tell you, I would label everything out. I can do 1 bar stats, but the good thing is when I construct this interval, it shows me that stuff anyway. So why do it twice? Got it? So here's what we have. How do we find our interval? Do you guys remember on your calculator? Be careful. We're doing T's and we're doing a T interval. Okay, we're doing a T interval. You need to know the difference because soon we're going to be using the other stuff. Okay, so z-tests and stuff like that. So be ready. All right, so we have the data in. We don't have the stats. I'm not finding the stats and then putting them back in. I already have the data. What's our confidence level? Okay, so we're going to calculate. And we see our interval right there. So our interval is 16.488 because I'm too lazy to calculate it myself, which is perfectly fine. But then I need to go back and label everything. So X bar was 22.5. T-star is the only thing I don't have. We'll get that in a minute. Our sample standard deviation was 7.19. And N was 8. Again, it doesn't matter where it's at on your paper, just make sure it's there. How would I find T-star? Where do I go? Second bars, inverse T. We wanted a 90%, right? 95%. So what's my area? And then our degrees of freedom were 7. Good. So then 2.365. 2.365. You can do your interval for your Z's in your calculator as long as you write the formula and you label everything out. You guys understand that? All right. Conclude. We are 95% confident that the interval 16.488 to 28.512 captures what? The true mean amount of sugar. Say it again. In all manufacturers' soft drinks. Good. All right, give you just a second.
There's a parent on the phone in the main office wondering if their cell phone works out. Is their cell phone working?
Yep, we're going out. Y'all ready? One more question. So, yes,
You're not practicing it.
would you practice today?
No,
Okay.
but you're not cheerleading practice.
Oh, I thought you were talking about softball. Anna just came in and asked about
Sure.
that. No, Monday, we will.
That's fine. Because the football team is going to go to the commentary, y'all.
Well, is he gonna mess up all the desks, Mr. Davis? Ooh,
They're just going to take like 10 minutes, like talk to them.
Yeah.
Like teach them. They're not-
No, we're not. Mm-mm. We're good. Thank you. We'll have another interruption, I guarantee it. I think Kay will be in here soon. For real. All right. So here's the thing, when you're trying to find sample size for this, you still use Z-star, okay? That never changes. So if you're trying to find sample size, always Z-star. The only difference is the formula that you use for your standard deviation part. Everybody got that? So be aware of that. Don't use T-star on this. So it says a researcher would like to estimate the mean amount of time it takes to accomplish a particular task. A previous study indicates the time required varies in population with a standard deviation of 4 seconds. He would like to estimate the true mean time within 0.5 seconds at a 95% confidence. How large a sample is needed? It's always what it gives you. Yep. So what is your Z-star for a 95% confidence? 1.96. We're going to multiply that. What was our standard deviation that they gave us? 4. We don't know n. That's what we're looking for. Less than or equal to our margin of error is 0.5. How do we solve? Divide by 1.96. We get 4 over the square root of n is less than or equal to 0.2551. I do that little cheater method and interchange it so that we have 4 over 0.2551 is less than or equal to the square root of n. And then I just got to get rid of that square root. So I'm going to square it. And I just do all that at one time instead of typing it in 40 different times. You get 245.86 is less than or equal to n, which means that n has to be greater than or equal to 245.8, which means that our sample size has to be 246. Any questions? All right, so you have some multiple choice practice, and I'm going to just go ahead and give you the answers to that. And then if you have any questions about those, just let me know. Okay. So the first one is A, 2 is C, 3 is A. Make sure that you know this. Hold on. Make sure that you know what conclusions you can make. So like number 1, I know there's some like that ask you about the conclusions. I know there's one like this. How things affect it. This is interpreting the interval. You should not have any problem with that. Be careful and make sure that you watch this. Okay, so this one, here's the difference. This is what I'm talking about. There is a 90% chance or we are 90% confident. We know that this is not right. Okay, so don't pick one like that. Again, it has to have the interval in it. This one is more of your confidence level rather than your interval. Okay, so know that. Number 4 is E and number 5 is C. Number 5 is just like the ones we just did. You're finding the sample size. Look at this though. You need to make sure you know what a standard error is. Okay, so go back in your notes and look for standard error. It's a part of the formulas. Okay, know what a point estimate or a point estimator is. That's like your X bar and your P hat. Know what those are. Okay, is everybody good? All right. The back side, number 6 is 5. So see, it showed up again. What is the standard error? Are you ready for that? This one just has you check out the interval. Be careful on this one because it doesn't actually give you the interval. It gives you plus or minus whatever that is. So you guys should know, this will be the proportion, and then you just got to figure out which decimal is that Z star, T star, whatever, T star, P1 minus P over N. So this part is what these numbers are. Okay. Which of the following is the smallest sample size needed to guarantee the confidence level? Just watch it. This is proportions. That's what you need to know, is what the difference is. Know which one is proportions, know which one is means. But you know those two formulas. We went over it. An SRS of 100 postal employees, blah, blah, blah. A 90% confidence interval for the mean time. That's just doing the confidence interval. And again, they just don't put it together, if that makes sense. Okay, so this one, because it's a true mean time, is the T star formula. Okay, be ready for that. Same thing on this one. So the reason they do this is to keep you from using your calculator to find the interval. They make you do it by hand. So why do I teach you by hand? So you can see it that way. Okay, if it's on the free response, you can do it in your calculator. Just make sure you find everything. All right, do y'all have any questions? Everybody good?
So like, this is John. So if the mean.
Okay, so if, hold on. That you're talking about is if they do not give you a proportion and they ask you about the sample size. Yeah, no, because they'll tell you the standard deviation. We don't use a proportion in there. They'll tell you the standard deviation. Just remember both times you're estimating the sample size, you're using Z star.
So always have to do it.
Yes, yes. And it'll say the standard deviation from a previous study. That's the only way that we'll know. All right, so I'm going to stop sharing and stop recording. If you guys have